Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the another problem which is numerical number 2 based on the RL circuit. Okay. So basically in the those questions there is not mentioned that the resistance and inductor are connected in series. Okay. So instead of this word they are using the another word which is known as the coil. Okay. So coil means the resistance and inductance are connected in the series. So this is how we can identify that the both the element are connected in the series format. Okay. So in our question, the given values are that the voltage is given by 200 sine 100 pi t is applied to a coil. Coil means the resistance and inductance are connected in series. Having a resistance of the 200 ohm and the inductance of 0.38 Henry. So here we have to calculate the current and the power taken from the supply. Okay. So here the given is voltage which is equal to 200 sine 100 pi t. Okay. So this is our given voltage equation. So we know that the standard equation is equal to Vm sine omega t. So here the maximum value is equal to the 200. Okay. And the value of the omega is equal to 100 pi. Okay. So another important thing is that here we need the RMS value. Okay. So the RMS value of the voltage will be equal to E is equal to Vm by root 2, or we can say that E is equal to maximum value is given to us is 200 divided by root 2 at an angle of 0 degree. Okay. So this is our standard format. So here the value of the RMS value of the voltage is equal to now 141.42 at an angle of 0 degree. Okay. So we have calculated the RMS value of the voltage in the terms of polar format. Okay. This is our polar form. So from the given expression, as I discussed here, that here omega is equal to, from this equation, is 100 pi. So we need to calculate the XL. Now the XL is equal to nothing but the omega L. So here the value of the XL is now 100 pi multiplied by 0.38. Okay, so this is given to us here, the value of the L. Now XL is equal to 119.38. Okay, so we have calculated the value of XL. Now the total impedance is given by, we know that Z is equal to R plus J of XL. Now the value of the impedance is equal to 200, which is the value of the resistance, plus J XL. The value of the XL is 119.38. Okay. So this is the rectangular format. This is rectangular form. Now we need to transform this rectangular form in the polar form. So we will get the value of the Z is equal to now 232.9 at an angle of 30.83 degree. Okay. So here, in order to find out the current, mainly we need the two things. First one is the RMS value of the voltage divided by the impedance. So this is how we can calculate the value of the current. So in order to calculate the value of the current, firstly we need the voltage RMS value. So the RMS value of the voltage, which is equal to this 141.42. This is how we have calculated. And another value we required is that the impedance. So impedance we have calculated like this. Okay. Now the value of the current is equal to voltage, which is equal to 141.42 divided by the impedance. So the impedance value is, here the angle is, sorry, here the angle is at 10 degree of 0. Okay. So which is divided by the value of the impedance, which is equal to 232.9 at an angle of 30.83. Okay. So now the value of the current is equal to 0.608 at an angle of minus 30.83 degree. Okay. So this is, we have calculated the RMS value of the current. So what will be the maximum value of the current? The maximum value of the current is the root 2 times of RMS value. So which is equal to 0.86 ampere. Okay. So next, what we need is that here the expression for the current is equal to Im sine 100 pi t minus 30.83 degree. Okay. This is what we have calculated. The angle of the current is equal to minus 30.83 and the angle of voltage is equal to 0 degree. So if I write the equation of the current, then the equation of the current will look like this. Okay. So by putting those values, like Im is equal to 0.86 sine 100 pi t minus 30.83. Okay. So this expression will exactly like this here. Okay. In the place of the omega t. So this we will not change. Okay. So now another thing which is asked in the question is that the power taken for the supply. Okay. So next here we need to calculate the power factor. Okay. Now the power factor is equal to nothing but the cos of phi. Okay. So the cos phi is equal to the value of the phi is that the phase angle difference between the voltage and the current. So the voltage, the value angle of the voltage is 0 degree and the angle of the current is equal to 30 degree, 30.83. Okay. Now the cos phi is equal to nothing but the cos of angle. Okay. The value of the angle is 30.83 degree. Okay. So the value of the power factor is equal to power factor is equal to 0 0.85, which is the lagging. Okay, because of the RL type of the load. Now, as we know that the active power, the formula of the active power is equal to VI cos of phi. Okay. Vi cos of phi. So we know that the value of the voltage, RMS value of the voltage, RMS value of the current, and the cos phi value. The cos phi value is that 0.8586. Okay, and the value of the voltage is here, which is equal to 141.442. Okay, and the value of the current, which is equal to here 0.608. Okay, so by putting those value here, we will get the 141.42 multiplied by the current value, which is equal to 0.608 multiplied by the power factor, which is equal to 0.8586. So the active power is equal to P is equal to now 73.825 watt. Okay, so this is our the second answer, which is asked in the question, power taken from the supply. Okay, so this is how we have calculated the current and the power drawn from the circuit. So thank you very much. Kindly like and subscribe our channel.